Okay, question 11. We'll take a look. Let me hit the focus lock. First question asked me to complete the square. So the sensible thing is this spot here that each of these has got a factor of 3. So I can factor the 3 out and I can complete the square inside the bracket here. And then remember to multiply the 3 back in. So there you go. There's your completed the square format. Then it asks for the transformations that turn the x squared into this particular graph here. So I need to recognize that there's a horizontal translation with the vector, so making sure that I'm describing translations mathematically. There's the vertical stretch of factor 3, and then there's the translation, the vertical translation at the end, 0 across 3 up. The other thing that's important here is the order. The order in which they happen is defined by the order in which the order of operations within the function. So this horizontal translation happens first, then the stretch, then the vertical translation. And that's important. It's particularly important that the vertical stretch happens before the vertical translation, because if you translate first, suppose I translated, and then I stretched, well, this vertex gets pulled further away from where it would need to be. So we were also looking for the order there to be appropriate. Part C asks us to sketch the reciprocal graph. And so if we quickly put on the original function, I know that that's got an intercept of 6 there. I know that the vertex comes from here. So I've got the key bits of that. Then I know that 1 over that, well, 1 over 6 is 1 over 6. 1 over 3 is a third. I know that the minimum point becomes a maximum point as this approaches infinity. 1 divided by a really big number is a really small number, so this will be asymptotic to the axis. So there's the sketch that we were looking for the reciprocal graph. The range of that we can then see is that it goes as high as 1/3 and actually touches 1/3, and it's asymptotic to the axis, so y is greater than 0. So there was the range. E, starting to get into the calculus of this, talks about the integral of the function. So again, it's if you spot the 3 there, you can factor that out. Then that clearly is a little bit nicer to deal with. So I can make the substitution of u equals x minus 1 into there, so that du is also equal to dx. Then that integral will be rewritten as a third integral of 1 upon u squared plus 1, as we've got there. So that's part E. And then part F, prove that the integral, the definite integral between 2 and 1 of that function is pi on 12. So I'm going to use this version. I've got to swap the integral, instead of the limits of 2 and 1, I've got to then change them into limits of u. So this is u equals 1 and u equals 0. Recognize that 1 upon u squared plus 1 integrates to the arctan result, and so I can put those numbers into here. A third of arctan 1 minus arctan 0 leads me through to the pi on 12 result as required.